If you've ever built an AI application, you know this feeling all too well. You spend weeks, maybe even months, crafting the perfect prompt. It works like a charm on your machine, and then you push it to production, and boom, it just completely falls apart. So today, we're going to dig into why that happens and, way more importantly, how you can stop it. Yeah, and this quote just hits the nail on the head. The controlled, predictable world of a development notebook is a universe away from the chaotic, messy reality of a live product. That magic you felt, it quickly turns into this incredibly frustrating game of whack-a-mole, where you're just constantly putting out fires you never even saw coming.
And that right there, that leads us straight into what I call the production trap. It's that painful moment when your brilliant prototype becomes this brittle, high-maintenance system the second real users and real-world data get involved. So what exactly is going wrong here? Well, it pretty much boils down to three main culprits. You've got prompt and model drift. That's when the LLM provider updates their model and your perfect prompt suddenly gets weird. Then there's what we're going to focus on today, the hard coding trap. And finally, non-deterministic regressions. Now, all three are a huge pain, but that hard coding trap, it's often the most catastrophic and honestly, the most avoidable. So what is the hard coding trap? Let's break it down. It's when you treat your prompt like it's a config file for your entire business. You start putting things in there like prices, refund policies, or specific promotion dates, things that change. This couples your application logic directly to your content, which means every single time a policy changes, an engineer has to go in and deploy new code. You can see how that's a recipe for disaster.
And that is what leads to that feeling of whack-a-mole engineering. You're not building cool new features anymore, you're just endlessly patching a fragile system. You fix one problem, and two more just pop right up in its place. This image just perfectly visualizes that problem of non-deterministic regressions we mentioned. You might add one simple line to your prompt, something like, be more polite, trying to fix the bot's tone. You hit that mole. But then, completely out of the blue, the bot starts hallucinating facts or spitting out broken JSON. You fix one little behavior and you accidentally break two others. It is an absolutely maddening cycle. To make this all feel a bit more real, let's walk through a case study. We'll call it the Gate B12 Riot. It's a story about how a single hard-coded number in a prompt led to total chaos at an airport for our fictional company, Skystream Airlines. Okay, so check out this timeline. At 9 a.m. sharp, management sends out an email. The carry-on limit is now 7 kilos, down from 10, effective immediately. But just 5 minutes later, the engineering team goes into a do-not-disturb, heads-down sprint planning meeting. They have no idea this change happened. For the next few hours, the AI chatbot, chugging along on the old hard-coded prompt, keeps telling thousands of customers that 10 kilos is totally fine. By 1 p.m., those same customers start showing up at the gate, and you guessed it, total chaos. And this just brilliantly illustrates the entire anatomy of the failure. Over on the left, you see the conflict, management's new rule versus that old hard-coded prompt. In the middle, you've got the time bomb, that 4-hour lag where engineers are totally in the dark. And on the right, the consequence, a full-blown riot at the gate with furious customers, overwhelmed agents, and a massive hit to the airline's reputation and bottom line. So how could all of this have been prevented? It all comes down to one simple architectural principle. A golden rule that, if they had followed it, could have helped them avoid a riot at their own gate. I want you to really think about that for a second. What was the core mistake Skystream's engineers made that led to this catastrophe? The answer isn't about, better communication or faster deployments. It's about how they fundamentally structured their prompt. The principle is all about the separation of behavior and knowledge. Your prompt is the perfect place to define behavior. As you can see on the left, that means telling the AI its tone of voice, the logical steps it needs to follow, or the output format you want, like JSON. But it should never contain volatile knowledge, things like prices, company policies, or specific dates. That information belongs somewhere else, like a database or an API, where it can be updated in an instant. So the single most important thing to take away from this is this. Prompts define how the AI should act, not what it should know. Knowledge changes all the time, but the AI's core behavior, its personality, its process, that should be stable. By keeping that volatile knowledge external, you can update it instantly without ever having to touch your code. Ultimately, the solution is to architecturally separate the brain, which is your LLM, from the book, which is your company's knowledge. The prompt's job is to teach the brain how to read the book, but the book itself has to live somewhere else. The big question then becomes,
how do you actually build that book and teach the AI to reference it on the fly? And that, well, that's a topic for our next explain.